What if we could clear Alzheimer's plaques from the brain in mere hours? This isn't science fiction. It's a groundbreaking discovery that's already been achieved in mice, offering a glimpse into a future where this devastating disease might be managed differently. This disease relentlessly steals memory, identity, and precious time. Alzheimer's isn't just the sadness of an aging brain. It's the insidious buildup of sticky amyloid beta plaques and neurofibrillary tangles, which are the hallmarks of this progressive neurodegenerative condition. Scientists have now uncovered a revolutionary method to repair the brain's crucial cleanup gate, the blood-brain barrier, allowing these harmful plaques to exit instead of accumulating. This approach targets the very mechanism that fails in Alzheimer's, leading to waste buildup. But here's where it gets truly astonishing. What if this innovative approach, proven effective in mice, could actually work in humans, offering a new beacon of hope for millions suffering from this debilitating disease? This could fundamentally change our fight against Alzheimer's. The headline is incredible. Just 3 injections, utilizing a special nanoparticle technique, led to mice losing approximately 45% of their brain plaques within hours. This rapid clearance is a significant breakthrough compared to previous, slower methods. These weren't healthy mice. They exhibited significant cognitive decline beforehand, mirroring the human condition of Alzheimer's. Yet, after treatment, their performance in learning and memory tasks mirrored that of healthy peers, demonstrating a remarkable reversal of cognitive impairment. This remarkable improvement in cognitive function, observed in mice with pre-existing decline, underscores the potential of this treatment. However, it's crucial to remember this isn't magic yet, and the journey from mouse to human trials is complex and challenging. Let's delve into the fascinating mechanism behind this breakthrough. The blood-brain barrier, or BBB, acts as the brain's protective moat, safeguarding it from harmful substances and maintaining its delicate internal environment. However, in Alzheimer's disease, this vital moat weakens, leading to the accumulation of waste, specifically amyloid beta clumps inside the brain. This breakdown in the barrier's integrity is a key factor in disease progression. Instead of attempting to smuggle drugs into the brain, these ingenious researchers posed a different question. What if we could restore the moat's integrity, enabling waste to leave? This paradigm shift in thinking is what makes this research so promising. They achieved this by deploying nanoparticles specifically designed to target LRP1, a critical transport protein within the barrier responsible for clearing amyloid beta. LRP1 plays a significant role in mediating both brain A-beta production and clearance, making it an ideal target. This targeted action initiated a cascade, fixing the vessel, dramatically increasing clearance, and ultimately leading to a cleaner, healthier brain environment. The nanoparticles essentially re-enable the brain's natural waste disposal system. The promise here is profound, a potential pathway not merely to slow Alzheimer's progression, but to actively reverse its devastating effects, offering a new hope for patients and their families. However, we must face the reality check. Mice are not humans. Their brain vasculature, the network of blood vessels, differs significantly, meaning results from animal models don't always translate directly to humans. As one expert cautioned, it's too early to definitively say if this will work in people. So, should we be excited, or are we being misled by promising but preliminary findings? These are valid concerns that need to be addressed. These are excellent questions. Yes, this research is incredibly exciting and offers a novel approach. But no, there are no guarantees yet. The history of Alzheimer's drug failures serves as a stark reminder of the challenges ahead and the need for cautious optimism. Here's the big reveal. This study heralds a new era in Alzheimer's research, shifting focus from merely blocking symptoms to fundamentally repairing the brain's infrastructure. This represents a significant conceptual leap in our understanding and treatment strategies. It suggests that the blood-brain barrier isn't just a hurdle, it's a malfunctioning tissue itself. By fixing it, the brain's natural self-clearing system can be restored, allowing it to effectively remove harmful amyloid beta plaques. What's next? The critical phase of human trials. Safety is paramount. followed by determining optimal dosage, and finally, evaluating real-world outcomes to ensure efficacy and long-term benefits for patients. So yes, you've just witnessed one of the boldest strategic shifts in the fight against Alzheimer's. This single study is a powerful spark, not yet the roaring flame, but it ignites hope for a future free from this disease. If you want me to delve deeper into the biotech companies racing to translate this into human treatments, exploring the next steps and potential timelines, hit that subscribe button and join our community of science enthusiasts.